Algebra 1, Lesson 113, direct variation and inverse variation. So direct variation is very, very similar to our proportions, and inverse variation is as well. So I'll go ahead and I'll solve a couple practice problems here in our normal proportion method, and then I'll start explaining what a scale factor and the constant is. So the key words here are going to be the words direct and inverse. Right here we have a direct variation problem. They tell us the mass of a substance varies directly as the volume of the substance. So if we're doing mass to volume, we could create a proportion that says mass 1 over mass 2 is going to be directly proportional to volume 1 over volume 2. Okay. So then if we go back to our problem, they tell us the mass of 2 liters of the substance is 10 kilograms. What will be the volume of 35 kilograms of the substance? Again, liters is going to be the volume. So volume 1 would be 2 liters. Mass 1 would be 10 kilograms. And then mass 2 is 35 kilograms, but we need to find volume 2. So we'll go ahead and take those numbers and substitute them into the proportion that I just created. So again, mass 1 is 10 kilograms. So substituting for mass 1, I have 10 kilograms. Mass 2 is 35. And then volume 1 we know is 2 liters, and volume 2 we do not know. So we can go ahead and cross multiply to solve here. When I cross multiply, I get 10x is equal to 2 times 35, or 70, because 2 times 35 is equal to 70. From there I just divide each side by 10, and then I find out that x is now 7, or 7 liters, and that is the volume, which we'll see is correct in the book. So this is how we would do direct variation using what's called the proportion method. Now, using this exact same problem, I'm going to show you the scale factor or the constant method that they use. And the way that they use the constant method is that they would say, since it's a direct variation, that the mass would be equal to a constant represented with the letter K times the volume. So from there, what we would do is we'd just take mass 1 and volume 1 and plug them into this equation. So 10 and 2. So I'll go ahead and take mass 1, which is 10, and that's going to equal the constant K times volume 1, which is 2 liters. So now we have this equation of 10 kilograms equaling a constant value times 2 liters. The goal here in this scale factor or proportion method is to find out what the constant is. Once we find out what the constant is, we can then plug that into mass 2 to figure out what volume 2 is. So it's kind of like a two-step equation. You solve one equation for an unknown and then use that unknown to solve the second equation. So let's go ahead and solve for K1, or for the constant. So we just divide each side by 2, and then I end up getting that 5 is equal to the constant K. Now I can take this constant and I can plug it back into this equation, but instead of using mass 1, I'll go ahead and use mass 2. So I'll take the same equation. Mass 2 I know is 35 kilograms. That's going to equal the constant 5, or K, times volume 2. So once I plug this in, all I need to do is solve for V by dividing. That cancels. 35 divided by 5 gives me 7, and that gives me volume 2. So this is the scale factor method. This is the proportion method. You can use whichever method works best for you, but you can't ignore the scale factor method. It becomes very useful, especially when we start doing geometry and we start computing different proportional lengths and areas, but we'll deal with that when we get to that class. So these are two different ways of solving the same problem. Your book will only show you the scale factor method, but they both work. Now let's go to inverse variation. So inverse variation is, well, it's just the same thing but inverse. So this is direct here. Direct variation would be these two equations, right? What inverse variation does is it just flips one of the unknowns and makes it upside down. So for example, here we had mass 1 is to mass 2. In inverse variation, you would say mass 1 is to mass 2 as volume 2 is to volume 1. So the change is very slight, but you'll see that all we did was we took volume 1, volume 2, and we inverted them, or we flipped it upside down, hence the name inverse variation. If we were going to do the same thing with a scale factor, the equation would be mass is equal to the constant divided by volume, right? So instead of volume being in the numerator, we move it down to the denominator. So this is inverse variation, and this is how the formula changes. Now let's go ahead and apply this to a problem. So let's look at we'll look at this one. So this one doesn't use mass, it uses pressure instead. So they say under certain conditions, the pressure of a perfect gas varies inversely, which again is our key word to know we're using inverse variation, as the volume. So when the pressure of a quantity of gas is 7 pascals, the volume is 75 liters. What would be the volume if the pressure increased to 15 pascals? So even though it's in pressure instead of mass, it's fine, I can still do this. The equation would just be pressure 1 is to pressure 2 as volume 2 is to volume 1, again for inverse variation. Then I'll go ahead and plug in the information they give me, which is, they tell me when the pressure is 7 pascals, the volume is 75 liters. So this is pressure 1 and volume 1. So we'll go ahead and fill in pressure 1 and volume 1. So in my equation, pressure 1 is 7, and volume 1, which is going to be in the denominator, is 75. Then they tell me that pressure 2 is 15 pascals, and they want to know what volume 2 is. All right. So I go ahead and I cross multiply. I get 15x is equal to 7 times 75. And I'm going to go ahead and leave this one unmultiplied because I can tell that 75 is a lot easier to divide by 15. So now I go ahead and divide each side by 15. I know that 15 will go into 75 5 times. Or if you didn't see that, you could also divide by 5. But I know that it goes in 5 times, so that's going to be 1, that's going to be 5. 7 times 5 is 35, so x is going to equal 35. And since the problem is asking for volume and volumes in liters, the answer would be 35 liters. All right. So that's inverse variation using proportion. We'll go ahead and do the same problem using the scale factor method, which again, the equation for scale factor in this case would be pressure is equal to the constant divided by the volume. So first I'm going to solve for my constant. So I'll plug in pressure 1, which is 7, and then volume 1, which is 75. All right, so my constant, so the way I solve for the constant here is I multiply each side by 75 because it's the opposite of division. So again, we're using our rules of algebra. We want to move the number 75, so we use the opposite action, which is to multiply by 75. We do that to both sides. Let's see here, for 75 times 7, I know that 7 times 7 is 49, so 70 times 7 will be 490, and then 7 times 5 is 35, so 490 plus 35 is 525. So 525 is equal to the constant, or K. Now all I have to do is plug in the pressure 2, which pressure 2 is 15. So I go back to this equation. Pressure 2 is 15. The constant I know is 525. And then the second volume I do not know. Now this one might be a little bit tricky since our unknown is in the denominator. But all we have to do is get it out of the denominator. So to do that, we would multiply both sides of the equation by the least common multiple, which would just be v. So this would be times v, and this gets multiplied by v. That cancels, and my new equation becomes 15v equals 525. Last step is to divide by the number 15. That cancels, and then 15 goes into 525. I am not even sure how many times. That's a tough one. We'll go ahead and do a division algorithm for this one. So 15 into 525, I know that's going to go in 3 times, which will give me, which will give me 45. When I subtract, I get 7, 75, and then if I remember correctly, 15 goes into 75 5 times. So my answer is 35 again, which matches our answer up here. So again, these are the two methods for direct and inverse variation. If you have any questions, let me know on Moodle, and I will see you in class.